All right, so this is how we would graph form B of this rational function's exit ticket. Let's again start by looking for my horizontal asymptote by looking at my degrees. Again, both my degrees are 2 on my numerator and denominator, so I'm going to divide my coefficients. So 2 divided by 1 is y is equal to 2. So I'll get my horizontal asymptote knocked out there. Now I'll do my vertical asymptote, and to get that and everything else, I'm going to have to simplify my function. So I'm going to factor out a 2 and get x squared plus x minus 12 divided by x minus 3, x plus 2. And I'll simplify my top further to be 2 times x plus 4 times x plus, or not x plus, x minus 3 divided by x minus 3, x plus 2. My x minus 3's will cancel out, so my simplified form of my function will be 2 times x plus 4 divided by x plus 2. And then to get my vertical asymptote, I'm going to set my denominator equal to 0. So x plus 2 equals 0. X will be equal to negative 2. So I have my asymptotes. I'm going to go ahead and graph those now. So x equals negative 2 will be this point, or this line right here, this vertical line. And then my horizontal asymptote of y equals 2 will be this horizontal line at x equal, or at y equals 2. And next, let's work on figuring out our hole and our coordinate of our hole. So we crossed out x minus 3, so we'll set that equal to 0. So I'll have x is equal to 3. I'm going to take that and go ahead and plug that into my simplified form to get my y coordinate. So I'll have 2 times 3 plus 4 divided by 3 plus 2. 3 plus 4 is 7 times 2 is 14 divided by 5. Yes, you can get fractions. No, they're not the most fun thing to graph, but yes, you can get them. So my coordinate is going to be 3 comma 14 divided by 5. 3 and go up. That's going to be about right here. And again, clearly mark my hole there. Then I'll do my x-intercept. That's when I set my numerator equal to 0. I'm going to do that of my simplified form. So I'll have 2 times x plus 4 equals 0. Divide both sides by 2. I will get x plus 4 equals 0. And then subtract 4. I'll get x equals negative 4. So my x-intercept is going to be negative 4 comma 0. Plot that point there. And then my y-intercept, that is when I plug in 0 for everything. So I'll have 2 times 0 plus 4 divided by 0 plus 2. 2 times 4, because 0 plus 4 is going to be 8. And then 8 divided by 2 is 4. So I'll have my y-intercept at 0 comma 4. I'm going to get one more point here at least so I can have this have 2 on each side. So if I go from where my asymptotes intersect, go up 1 and then right 1, 2, 3, 4, 5, I can also go about down 1, not exactly 1 because it's 0.8, and go left 5, 1, 2, 3, 4, 5. I should have another point right here. And let's just get one more point for good measure here. Let's get one at negative 1. So I'll do it at the top. Ooh, not like that. 2 times negative 1 plus 4 divided by negative 1 plus 2 will give me negative 1 plus 4 is not negative 3. Positive 3 times 2 is 6 divided by 1. So it'll be at 6. So if I go up 1, 2, 3, 4 into the right 1, I can go down 4, 1, 2, 3, 4, and to the left 1. So I'm going to go ahead and connect my dots here to graph. And I'll do it on the other side as well. And that is what my graph, a sketch of it. It's not great, but that's what it should look roughly like. And now let's do the domain. So I'm going from left to right, including looking out for where my x cannot equal 0. So that would be my asymptotes and my holes. So I'll start with negative infinity, comma, my first asymptote at -2. So to -2, union, -2 to, we keep going, we reach our hole at x equals 3. 3, union, 3 to infinity. And then for my range, I'm going to start at the bottom, negative infinity. I'm going up until I hit my horizontal asymptote at y equals 2. So 2, union. Then I hit my hole, which has a y coordinate of 14 over 5. So 2 comma 14 over 5, union. And then we keep going up forever. So 14 over 5 comma positive infinity. And so that is how we would graph form B.